All right. Hi, everyone. This is our last lesson of Mod 5 Part 2. It's 5.9. Um, and this is going to be solving trig equations. So the biggest difference between these ones versus 5.8. So in 5.8, remember that you could not work with both sides of the equation, right? So like you couldn't cross multiply, you couldn't like subtract one thing to the other side. You had to pick a side, work with it because the direction said to verify. That's the big difference. So in 5.8, you were verifying identities versus in 5.9, you are actually solving. So because it's solving, you are welcome to move things on either side of the equation and you can work with both sides of the equation, okay? So the directions are going to read, find the solutions on the interval from 0 to 2 pi. That means that they want the answer in radians. This is going to be extremely helpful. In fact, this entire module is going to be extremely helpful for you guys if you plan to go to Intro to Calculus. Intro to Calculus is going to be huge trig based and algebra based. So very much from our mod 6 and this mod 5 part 2. Okay. But your answer is going to be in radians. And so we're really not going to use our little cheat sheet in this task as much because we're not verifying identities. Instead, we are solving for them. And because we want our answer in radians, if you guys remember from mod 6, when we talked about all students take calculus, that's going to be helpful to us. Creating those angles and reference angles is going to be helpful. And that is all from the unit circle. So if you guys want to have your unit circle on hand, that might be a good idea. Okay. So let's just jump right into it. Let's start with number 1. So we are solving. So basically your variable here is going to be this guy. So my goal is to isolate sine of x. So just pretend like that is your entire variable. Pretend like the whole thing is x. So we want to solve for this, right? So how would I get this by itself? Well, first I would add root 3 to the other sides, right? So now I have 2 sine equals root 3. Okay, now I still need sine by itself and it's being multiplied by 2. So how do I get it alone? I divide both sides by 2. Now I have sine of x all by itself. And it's equal to root 3 over 2. Now, we are not done, okay? Because it said find the solutions on the interval from 0 to 2 pi. So I want my answer in radians. Basically what this is saying, that sine is equal to root 3 over 2. And if you guys remember, sine is equal to y over r, which on the unit circle is just y over 1, which is just y. So we're basically trying to find where on the unit circle is your y value of the coordinate point equal to root 3 over 2. Okay, so a couple of different ways you can do this if you don't have a unit circle is going back to the all students take calculus. So do you guys see how this is a positive root 3 over 2 instead of a negative? So I want my y value to be positive. So where is sine positive? In quadrant 1, because that's all, and then in quadrant 2, because that's sine. This is tan, that's cosine. So sine is negative down here, so sine is positive. So it's definitely going to be in one of these 2 quadrants. So what is that telling us? Well, y is equal to root 3 over 2, positive root 3 over 2, in 2 different quadrants. So how many answers should you guys have? 2. Okay. So where is y equal to root 3 over 2? Here, which is at pi over 3. Don't say 60 degrees because the directions did ask for it in radians. So y is equal to root 3 over 2 at pi over 3, and it's also equal to pi, root 3 over 2 over here. So this is quadrant 1, this is quadrant 2. Just like I said, 2 different answers. So your 2 answers for this problem are pi over 3 and 2 pi over 3. And that is how you solve or find solutions on the interval from 0 to 2 pi. So we basically get our trig completely by itself, and then we find, okay, where on the unit circle is it equal to that value? Here and here. Does that make sense? Okay. Let's try, maybe if you guys want, go ahead and pause this one. This is a pretty easy one, just like the previous one. So it's very similar to number one if you want to go ahead and pause the video and try this on your own. Again, I highly recommend that you're trying during this if you plan to take Intro to Calculus. If you plan to take Intro to Calculus next year and you haven't been trying this whole time, no, drop the course. It's so hard, you guys. They are preparing you for calculus. So trust me, it's gonna be very beneficial for you to try now in Math 3. And you'll be like, yes, it'll take some time to remember this because you guys won't take it till the spring, but you'll at least be like, oh yeah, I kind of remember that. So go ahead and pause the video and try this one. I'm only gonna put up the answer. So if you wanna try this, pause it now. So if you solved all the way through, -4 divide by 2, you should have got sine of x equals 1/2. But remember that you're not done yet. That's not the final answer. I need this in radians. So where on the unit circle is y equal to positive 1/2? Pi over 6 and 5 pi over 6, quadrant 1 and 2. So those are your two answers if you did this right. Okay. Let's move on to number 3. So again, we're solving, right? And this is what we're solving for. So what's our first move? Divide by 3. Okay, so cosecant squared equals 4 over 3. Now this isn't cosecant by itself. My goal is to get cosecant completely by itself. So how do I undo a square? I square root. Okay. And just remember, when we square root fractions, you do the square root of the numerator and the denominator. So both of these are being square rooted. Let's simplify a bit. What's the square root of 4? 2. And square root of 3 is square root of 3. And then you can actually leave it like this. You don't need to go ahead and rationalize the denominator, meaning multiply both top and bottom by root 3, and I'll show you why in a second. But what happens when you guys square root both sides of an equal sign? What do we need to include? A plus minus, positive and negative. Okay, so this is what cosecant is equal to. What do we know about cosecant? Cosecant is the reciprocal of sine. So if you know what cosecant equals, don't you think it'd be a little bit easier to think about it in terms of sine instead of cosecant? So what is sine going to be equal to if this is cosecant? The reciprocal, just flip them. So this is equal to plus and minus root 3 over 2. So because we're talking about sine now, this means the y value on the unit circle needs to be equal to positive and negative root 3 over 2. Now remember, in problem 1, we already found the two positive root 3's over 2. That's quadrant 1 and quadrant 2. So I need the two negatives up as well. So what is that telling us, this plus minus? We're going to have 4 different answers, one in all 4 quadrants. So this one, that's quadrant 1, where it's equal to positive root 3 over 2. 2 pi over 3 is quadrant 2, where it's equal to positive root 3 over 2. Quadrant 3 is 4 pi over 3, because on the unit circle, that's where y equals negative root 3 over 2. And then in quadrant 4, at 5 pi over 3, the y value equals negative root 3 over 2. So this one had 4 answers. A little bit tougher. All right, let's keep going. Number 4. Now, I'm gonna start this one. I'm gonna do it in pencil because I'm gonna end up erasing it. The only reason I'm showing you this is because this is typically a common mistake that a lot of people do. So please don't write this down. So just watch me. This is what a lot of people do. right? Then they go, oh, I can divide by sine. Now I have sine squared equals 4, and I can keep going. You don't want to do this, okay? Because by dividing by sine, you just got rid of an answer. So you're only going to get some of the answers. So please never divide both sides by trig. Sine, cosine, tan, secant, cosecant, cotan. Don't do that. Instead, we're actually going to pull one of our tricks from 5.7, 5.8, and we are going to take out a greatest common factor. So what does this and this, these two different terms, what do they have in common? They each have a single sign. So let's pull out a sign. Let's divide each of these by sine, but I'm not dividing it to the other side and getting rid of it. I'm pulling it out as a greatest common factor, so it's still there. So what do we have left over? What's sine cubed over sine? Sine squared. Minus, what's 4 sine over sine? That's just 4. So because I did that factoring move, I now have two separate equations I can set equal to 0. Okay. So we have sine equals 0, and we have sine squared minus 4 equals 0. And now I can solve. So this is the first time where you guys have two different equations, and both are going to count as answers. Okay, but we didn't get rid of an answer by dividing it to the other side. So this one's already solved, right? Sine equals 0, or sine of x equals 0. So that one's already solved for. Let's go ahead and solve for this one. I'm going to add 4. So sine squared equals 4. Sine still isn't by itself, so I need to add square root both sides. And remember that we always add a plus minus. Now I have sine by itself, and it's equal to positive and negative. What's the square root of 4? 2. Okay, so now comes in the unit circle part. So remember that sine is equal to the y value. So if I want a y value to be equal to 0 on the unit circle, where is that going to be? It's going to be at 0, or you could have said 2 pi, same thing, either one, and at pi, right? So here at 0 or 2 pi, it's at 1, 0, and that's y equals 0. And then same thing over here at pi, it's negative 1, 0, so the y is equal to 0. So that's the only two places on the unit circle where the y value is equal to 0 because it's sine. So I usually do 0 and pi, but if you put pi and 2 pi as your answer, that's totally fine as well, because 0 and 2 pi are the same position. All right, next up, this guy. So that's part of our answer. Here, where on the unit circle is y equal to 2? Y equals 0, y equals a half, root 2 over 2, root 3 over 2, 1. Is there anywhere on the unit circle where the y value is equal to positive 2 or negative 2? Nope. So this part has no solution. If we didn't have this section and this was my only problem, then the entire answer to this would be no solution. But because we had the two separate equations, we do have solutions. So this just becomes obsolete, and your only two answers are 0, pi, and pi. All right. So hopefully these aren't too bad, especially if you're good at solving and comfortable with your unit circle. Let's just do a few more practice. Okay. At this point, if you want to pause the video and try these on your own, you are more than welcome to. We only have 4 left, and I'm going to do all of them just to have them. But if you're planning to take Intro to Calculus, I highly recommend that you guys try now, because trust me, you're not going to want to deal with that stress case next year if this is all technically new to you. So, all right. So again, we're solving. So I'm going to add 1. I get 3 tan squared equals 1. Divide by 3. I'm solving for tan. Okay, square root. Don't forget the plus minus. So now I got tan by itself, and it's equal to positive and negative square root of 1 over square root of 3. Simplify a little bit more. The square root of 1 is just 1, and the square root of 3 is root 3. Now, tans are definitely the hardest because if you remember, tangent is equal to y over x, or sine over cosine, right? Lift this up a little bit. So tan is equal to y over x. So that means I need to find on the unit circle, when I divide a y by an x, it should be equal to positive and negative 1 over root 3. So the first thing I like to do is like process of elimination. So if you guys think about the 4 corners, the 2 pi, the pi over 2, and the 3 pi over 2, you guys see how their x and y's are either a 0 or a 1 for all 4 of those? Do you think you're going to divide these and get a root 3 in your answer? No. So that's 4 already gone. How about the 45 degrees? Do you think you're going to divide root 2's over 2's by each other and get a root 3? No, a root 3 isn't going to magically appear. So you definitely know it's going to be one of these, right? Yeah, so let's try it. May as well try pi over 6 first. So I'm going to do the y value, which is 1/2, divide it by the x value, which is root 3 over 2. And we're going to do some KFC, keep, change, and flip. 2 over 2 is 1, and what are we left with? 1 over root 3. Perfect. So that means that one of my answers is pi over 6. Now, I have a positive and a negative 1 over root 3. So if one of my answers is pi over 6, what do you guys think another answer would be? 5 pi over 6. Because if I divide these, I'm going to get negative 1 over root 3, and that's okay because I want a positive and a negative. So again, referring to all students take calculus, tangent will be positive in these two, and tangent will be negative in those two, and I want them to be positive and negative. So I'm going to take all 4 pi over 6's. So here's quadrant 1. Quadrant 2, quadrant 3, and quadrant 4. Those are my 4 answers, where tan is equal to positive or negative 1 over root 3 because tan is y over x. So when you divide y over x at those 4 positions, you get this. Okay. Okay. Moving on to number 6, if you're still with me. Again, a big mistake that people are going to do right away is they're going to want to divide cotan to both sides. But what did I just do? Yeah, it looks way easier. I would so rather deal with cosine squared equals 2. But what did you do by canceling out one of your trigs? You lost answers. So we never want to divide by a trig. You will lose answers, and that's not good. So instead, let's bring everything to one side. Okay, so this gives us cotan times cosine squared minus 2 cotan, and that equals 0. And then this will lead us kind of back to, I don't know if I still have it out, but the GCF problem. So what's a GCF here that I can pull out? A cotan. So let's pull out a cotan, and what would be left if I got rid of that cotan? Cosine squared minus 2. So that was my GCF. So now I can separate this into 2 different equations. I have cotan of x equals 0, and I have cosine squared minus 2 equals 0. This one's already solved for, so I'll come back to that, but let's go ahead and solve this guy. Let's add 2 to both sides. Square root. Cosine equals plus and minus root 2. All right, let's think about the unit circle. Let's do cosine first. So cosine is x, right? So where on your unit circle is the value of x equal to positive or negative square root 2? It doesn't exist. The closest is root 2 over 2, but that's not the same. That's not what we're asking. So this part has no solution. There is nowhere where cosine is equal to positive or negative root 2. Let's go back over here. When does cotan equal 0? Well, to remind you, cotan is the reciprocal of tan, so it's x over y. So when you divide x by y, when do you get 0? Well, we definitely know it's not going to be like a pi over 6 or pi over 4 or pi over 3, right? It's probably going to be one of the ones that has a 0 in it, right? So if I'm dividing x by y and I want it to be 0, where should 0 be, in the numerator or denominator? You want 0 to be in the numerator because that equals 0. If it's in the denominator, it's undefined. So basically, I want to find on the unit circle, where is x equal to 0? So not at 2 pi. Here we go, pi over 2. Not at pi, but at 3 pi over 2. So my two answers here are when x equals 0, because x over y equals 0. And that is at pi over 2 and 3 pi over 2. So those are my two answers. If you're still with me, let's finish this out. Again, if you're taking Intro to Calculus, you should definitely still be here. Okay, same thing with number 7. We don't want to add this sign over and cancel signs. Never, ever, 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 ever cancel trig. So instead, we're going to pull out a greatest common factor. And if you want to pause the video and try this one on your own, please do so. Two separates. This guy equals 0, and this guy equals 0. This guy's solved for, this guy's not, so let's do that. Don't forget your plus minus, and you guys don't even know how many times I have seen people just leave this as square root of 1. What is the square root of 1? It's 1. All right, so we have two sign values. We already know that sine is equal to y. So when is 0 equal to the y value of the coordinate point on the unit circle? At 0 and at pi. You also could have said 2 pi, 2 pi and pi. So that's part of our answer. Now, where is the y value equal to positive or negative 1? Well, the y value is equal to positive 1 at pi over 2, and the y value is equal to negative 1 at 3 pi over 2. So I have 4 answers here. This is where it's equal to 0, and this is where it's equal to positive and negative 1. So it's those 4 corners. All right, guys, last one. Let's do this. Number 8. This one's last because it's actually really tricky. You're not going to see any problems similar to this in Math 3, but you definitely will in Intro to Calculus. So with this one, I actually need to use our trig identities cheat sheet. This is the only problem where you had to do it. So cosecant is equal to 1 over sine because they're reciprocal identities. And because I'm solving here, I'm not verifying, I'm solving, you guys can cross multiply. So this is 2, and then sine times sine is sine squared. 1 times 1 is 1. And now I can solve from here. Okay. So we can divide by 2, divide by 2. So sine squared equals a half. And I'm going to square root, and don't forget my plus and minus. So now I got sine alone, and it equals plus and minus the square root of 1 over the square root of 2. The square root of 1 is just 1. And then let's go ahead and rationalize our denominators. So we get plus and minus root 2 over 2. We definitely know that's on the unit circle, right? So where is sine equal to positive and negative root 2 over 2? That's in 4 places, the 45 degrees, right? So it's at quadrant 1, 45 degrees, quadrant 2, 3, and 4. So you have 4 answers. Again, it's all the pi's over 4s. So it's going to be pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So this is quadrant 1, where where y is positive root 2 over 2. This is quadrant 2, where it's positive root 2 over 2. This is quadrant 3, where it's negative root 2 over 2, and this is quadrant 4. Yay! All right. Let's get into homework. So your homework is to do RSG 5.9. And you are only going to do numbers 1, 3, 4, 5, 8, and 10. Okay, so 6 practice problems on here. And in the RSG packet, this is on pages 13 and 14. Okay. Awesome. And this is the only homework this week. Because of the short week, so we didn't have school on Monday. No homework, but the next video will be if you guys want some extra practice, like together with Modify Part 2, that'll be the other video that I post, which is going to be this 5.9 day 2 classwork. That's what I'm going to be doing. Okay. Have a good day.